Hello, so this is our presentation for the frog bot that we made. I am Lily.
And I'm Ace.
I'm Will Duncan.
Okay, and this is our presentation. So for the problem description, so the problem that we were faced with was that we had to build a robot that had 4 legs, was made with Arduino, and was able to properly walk and withstand the tests that we were given. So for the for the design specifications, so as I stated, it has to have 4 legs, has to be made with Arduino. All the parts had to be made like within the lab, so like 3D printing, using everything that we had given to us. And so some of the specifications that were specific were, as stated, must be a quadruped, must walk on all 4 legs, so it has to walk successfully. It must be durable, and it must operate autonomously, so that means like it can't be connected to another computer. It has to be just one bot all on its own. It has to, the design had to be made in CAD. It had to be powered and driven by Arduino, as stated previously. It must be original. Like obviously the code can be tweaked a little bit, but the overall design of it had to be original. And there could be no temporary joinery. So that basically means like couldn't use tape, couldn't use string, nothing that held everything together. It had to be all just conjoined properly.
And so we then had to decide what were we actually going to do in order to accomplish all of this stuff. And so my first idea, we were going to go with a spider, and we would have 4 legs, and they would move in this sort of motion, so that we would think that it would be more balanced because it was lower to the ground, and that it would be pretty easy to program because each of the 4 legs could share code with each other. So it'd be a pretty simple concept to be able to just make it go forward. And it would also sync really easy because obviously there isn't 4 legs moving at separate times at all times. Yeah.
So on my end, with the actual designing, a lot of the things I had to look at was weight distribution. So one of the cons for this design would be a lot of weight on the legs because it requires more joints than the other designs would.
Okay, and then our next thing was kind of a classic design, like what you would immediately think of whenever you thought of like a moving robot. But there was also like a ton of problems with that because in it being tall, it would fall over easy. All the legs had to be differently like moving at all times, so it'd be really hard to like sync up so that it would actually move. However, it'd be nice and big, so there'd be a lot of room that we could put all the mechanics in order to make that work. And there was a ton of resources. Like if you went online, everybody and his brothers made a dog, so we would be able to use their resources in order to make ours. But then our last one was a frog. So we were thinking it can hop, because after we talked to Freddie, he said it would be okay if it could just hop instead of walking. So we would be like, okay, that's simpler and it's a low center point. However, literally nobody, whenever we looked this up, has done something like this except for like one person in like 2009. So we didn't have a lot of resources in order to go off of, so a lot of it just came straight from us. However, we had to think about the power that it would need in order to get itself off the ground, which was one of our huge like stopping points whenever making this design, is because an Arduino can't really make that much power in order to get it off the ground.
Yeah, and something to add to this is that with the frog design, not only did it make it completely original, since there was like not that many other designs along with it, but it also gave us a challenge when making the code, since it was different from compared to like the typical walking. We had to figure out a specific code that would work for the hopping motion.
And so I had to make a decision. Well, we had to make a decision to see which one we would actually choose. And so I made this chart. This chart works by you would line up each of your criteria, like each of the things that were specific for us that helped us design. So room for mechanics and the simplicity, the balance, the syncing, the resources, all of that had to come into consideration whenever we had to decide which one we were gonna do. So I lined up all 5 of our choices, and each one was tweaked to what we thought was gonna be best for that design. So we had a basic and then a more created, like a better design. And so each of these were ranked based off of what would be most important. Like a room for the mechanics, it was okay if that wasn't like the main priority because we could just add some on the bottom or something like that. So they were weighted differently. And whenever we ranked each of these, we ended up deciding on our second frog design being the best one we could do. And so as we were doing that, we decided to go against the hopping and to make it actually walk. And so whenever we were designing the CAD designs, like whenever I designed these, I had to take into account like what the legs, how they would work in order to make them actually withstand the weight of it, and how each one would actually like have room, how it would go together, and how it would be able to be held together.
If you could go back to that one. I remember when we first did the CAD designs and printed up really simple, like first mock-ups of it, the legs were actually super, super tiny, which was really funny because they were like this big, so we had to go back in and make them bigger and like proportionate to the body so it would actually move the way we wanted it to. So for our measurements for our whole frog, this is obviously like the final product right here, but you could see that when designing how big we should make it, a lot of the account was like trying to see how much stuff we needed to put in it in order to fill up that space. So kind of taking a basic measurement of the size of the Arduino and the battery and all of the things that needed to stick out and the little chipboard that we had putting in there to make it all fit. So we ended up deciding on this box that was it was pretty rectangular. It was 4 by 5 with 2 inches. It was 2 inches high. So kind of this like boxy design in order to have like enough room inside, but not too big to where only our simple legs could still move the entire thing up. Our legs, we ended up making about 1 inch long for each one, and then using the rubber on the bottom as well as screwing them in with the epoxy to kind of like seal it all together so that they would not move. An advantage of this design with the epoxy attached straight to the plastic part of the servo motor was that we could still unscrew and rescrew them in case the legs broke or anything like that. This also allowed with just the one to get the maximum amount of movement out of this, like the fastest we can make each leg move. So here's all the components of our robot. You can see the base plate that we made, I put little magnets inside and glued those in so that it would be easier to put on, and then it was a very tight fit in everything inside. It doesn't look like that, but you can see that some of these wires are sticking out, so I ended up cutting into the faceplate that I made there to have it be completely flush and that it would all stay together. Right here you could see the switch that was sticking out. In order to flick it, we made it look like a little tongue on the base of the robot, as well as the little mascot that was painted with the little gold chain. And then for our drop test, one of the things that made it survive was little dabs of this hot glue over here to cushion the impact, as well as like just the overall weight distribution being really even with it because of its super, super square design. Anything else to add? So for all the testing with the code, what we ended up finding originally was something that kind of controlled all of them at once, which didn't really work out. So what I ended up doing is making a code that would control the front and back simultaneously, so that it was only one set of degrees for the front and back legs, so that it would simultaneously move, so that it would move the weight as evenly as possible in order to keep it going in the straightest way it could. It did survive the drop test, but then unfortunately right after, the robot went missing mysteriously from the room over some kind of point in time after it was put down where it was always being worked on, so we're not really sure about that. But
so yeah, every day that we worked on this, I took about a minute-long video to show what we had done each day, and so it was mostly my commentary being like, okay, this is what we've created, this is what we need to work on, and so I published those all to YouTube. I'm not going to click the link because it'll just go away from the project, but there's about, I want to say we worked on this since January, so there's one for pretty much every day we worked on this. It shows what we did each time. So, and here's what we had to learn from this, because as we've obviously never built a robot before, so there was a lot of things that we had to figure out as we did it and moved into this.
So like one of the biggest issues that we faced was like the organization of everything. So obviously we were able to have like rubrics for basically everything we needed to do, thankfully. So with those rubrics, what we did was we sectioned the amount of work that we wanted to do for each day, so that way that it wouldn't create such like an overload of work towards the end of the project, and that way we were able to work on little things here and there throughout the day. So with organization, we did pretty good with that. The only thing I would recommend would basically just be like how to
Well, one of the problems that we had that I guess will kind of lead on to the solution was
Mhm.
when we did our own things as part of the group, we tended to like organize them in our own way instead of having like a set like way to do it so that it would be easier for everyone to do it, whereas we just kind of made our own separate parts of everything. So it was hard for people to get in on others' work for it in that kind of way, because that also goes along with the distribution of work. Like
Mhm.
once you had your own little section of the project, it was kind of hard to break off and work together if all of your organization was put together into one thing.
Yeah, like I did all of the like the CAD stuff and the preparation for it online, all the you know, or the design and stuff like that. I did all of that, and then we built it all and coded it all. And as we were trying to work together and make the actual final presentation, it was hard to make all of that be cohesive.
Get every part of it together as one solidified like project or robot.
Mhm.
So yeah.
So yeah, that's our presentation.
Thank you.
Thank you.
Thank you.